Hello everyone, we are here to talk about a AI-powered social media ad performance predictor that we built for a mini project. This is going to be a future of AI ad strategy, from the guesswork to the precision. This meta ad performance predictor is a cutting edge. It's an AI-driven platform that designed to transform how businesses approach the digital advising on the Facebook and Instagram by bridging the gap between the creative intuitions and the data backup insights. This tool allows the marketers to forecast the campaign results before the single rupee is spent. And we are using a predictive intelligence multimodal analysis which uses for the risk mitigations and estimates the cost trial and error space because the trial and error phase is ultimately costly. So we bought this AI powered social media performance predictor to mitigate that. The main statements of these problems will be the budget inefficiency and the wasted ad spend, an unpredictable audience engagement, and the creative fatigue and the stagnation, and the lack of pre launch performance metrics. The high marketing costs due to the trial and error testing and unproven AI creatives and unpredictable audience engagement. It's difficult to forecast how specific segments will respond to the visual and the textual element from the launch. And it's very hard to predict before the launch. And the lack of pre-launch performance metric, the reliance on lagging indicators after the money is spent rather than leading a predictive analysis. The scope of the project is exactly relies on the AI tools to solve the problems mentioned above. We are using a multimodal AI analysis and real-time engagement scoring and automated creative auditing and the niche specific predictive modeling. We are using a tailoring forecast each for the industry segments including the clothing, cosmetic, electronics and food and book for right now. We are using advanced multimodal AI diagnostics like visual content analysis. We are using a mobile net VA. It's a high compute vision model to extract the meaningful platforms from the ad images that are typically difficult for the human to analyze to perceive. And we are using a textual sentiment analysis, implementing the NLP based diagnostics to evaluate the psychological impact of the captions, identifying the power words, and assessing the sentiments before the ad goes live. And scalability and future proofing. We have done a future proofing like cloud first infrastructure, establishing a robust server side environment, replacing the local host in the future, capable for handling the massive parallelism and thousands of concurrent AI requests. And the privacy first and compliance, integrating the conversation API and the first party data strategies to ensure the accurate attributions in evolving the privacy centric digital landscape. The methodology of this project that we used is the data collections. It has a initial phase involving the aggregator specialized data set for the 200 plus campaigns records. We are using the five industries right now, that is clothing, electronics, foods and books to provide the diverse foundation of the AI training. And we are using a second step is to data processing. We have took the data and collected data in the five segments and we using the parameters like budget, audience size are normalized using the standard scalar, and the platforms and timings are encoded via the one hot encoder to ensure the numerical consistency of the model pipeline. And third, we are using multimodal development, as I said before, vision engine and predictive regressor and creative diagnostic integration. We are using OCR implementation. It is integrated to analyze the text to the image ratios directly to the uploaded creatives. NLP processing and the AI captions are vectorized using the TF vectorizer to evaluate the presence of the high conversion and the power words. And of course the web app deployment and testing. The user friendly Steam dashboard is built already where the marketers and the customers that can upload the assets and receive the instant plotly guide start of visualization of the predicted engagement score. That's the highlight of this project. The hardware that we're using will be the basic hardware requirements or like CPU Intel 17, Ryzen 7 for the fast data processing, and GPU NVIDIA RTX 8 plus RAM. The GPU will be NVIDIA RTX 8 GB plus VR RAM for the AI image analysis. And the RAM will be 16 GB to handle the model execution smoothly. And the storage is 1 storage is 512 GB SSD for the quick data. And the software that we are going to use is the language that is Python for the core logic and AI, and the UI Streamline web dashboard for the AI models, MobileNet V2, and the random forecast. The tools that we are using is Easy OCR, the Plotly Gang chart. This implementation of the project, the first step is environmental setup. A configure Python with the Streamlit Skyline and TensorFlow libraries, and the feature extraction is integrated as a second step, where the MobileNet V2 for the image analysis and OCR for the text density check. As soon as we're setting up the environment, we are going for the feature extractions where when the customers of the market is upload the particular ad, this OCR, easy OCR will be able to recognize the text in the particular image. And third, the model is being trained. It trained random. Now I'm here to explain the sample coding. This is sample code of a project, the basic code that we able to understand how a project exactly works. First, we have to input the necessary libraries we needed, like input streamword.std and the CV2 and numpy as np and ecocr for reading the text in the image and TensorFlow. And we are using a MobileNet V2 as I said before, and the random forecast regressive regression. And we have to use a plotly graph for the chart, result chart for the last. And next, set page configuration. We are giving up title, meta, predictor, and the layout is BOY. And next, data ingestion and the pre-processing. This is where the basic pre-processing and loading of data is taking place. And we are the file bytes. We are using a variable file bytes, and we are using an array for getting the image file and reading it and storing it. This continuously happens, and the image RGB that's converted to colors. The RGB images is converted into color images. And next is bilateral filter for the noise reduction. Of course, the image that we get is gonna have a lot of noise in that, and we have to filter out for the noise reduction. So we are using this CV2 bilateral filtering. This is a data computer vision technique. Am I using a standardized for the AI engine? The image resized. Image is gonna be resized, and the image array, and the image is being resized, and image is being processed, and it gets stored in the variable called image preprocessed. And we're gonna return out the image as RGB and image processed. And next, I will take it as a model 2. It's a multimodal AI engine, right? So we have to after collecting the data and processing it and importing the necessary libraries, we have here to develop the action model of our project. That will be we are using a function called a load AI models that gonna load our mobile net V2 for the visual features. This model vision and the weights are immagnant, and that includes top will be false and pooling will be average. You have to initialize the OCR here, and the OCR read and using a particular attributes in that. So we have to return, and this we have to use after initializing the OCR. We are here to use the functions called run analysis. This is the image and image tensor and the visual model reader is actually happening. The image that we are going to give will be analyzed. The vision will be analyzed perfectly, and this video features like vision model predictor that set image tensor flow and the flattened. And we are using a OCR text audit, and then the results will be stored as a reader read text. We're going to use the function called read text of image. The text or area will be summed up for the results, and density will be calculated. Next module will be a UI dashboard, and we are using a basic title like meta ad performance predictor, and we are using a markdown, and we are using a slider bar. Like our particular project we are going to use needs a lot of precisions in features that we are going to give into. So we use a lot of slider bars to get the input from the user, so it will be much more precise. And we are using slider bars for the four things, four features of the particular ad that we're going to get. That's one for the industries, next for the budget, and next for the ad copy. After getting the industries and budgets and particular text, and the file will be uploaded. If the uploader file, we are using a if statement, if the uploader file have to load, when the file is uploaded, load the particular models and process the image and extract the writings from the image using the OCR. And last, generate performance. We just given a basic UI for generate button, and later on the future and predictions happens. The actual logic, the brain of the program here. The stimulator random forecast scoring logic and the base score influence with the visual variance and density complaints. The base score will be 50, and we're using penalties and final score. And after we, as I said before, we are using a GAR chart, like where like a particular predictions will be displayed in the visualization form, so the marketers and the users can know why this ad has this much of score, or the why this ad has been lower in score. It helps them to analyze where the area of the particular hat lacks, and it need lot of support to it. And after using the result, after prediction is made, the result is being displayed by the gang chat, and we have using a lot of captions, and we have also integrated AI technology, right, of where they will be giving a suggestion. There'll be suggestion given down, so people can actually see that what could be improved in the ad much more further to hit that higher score of engagement of the particular ad. These are the particular sample outputs. This is our This is our first UI of a project. We have given a lot of features like platform, product category, and our target audience age and budget and follower count. Follower count is need for the both Facebook and Instagram. And the posting time. The posting time causes the various differences in the predictions of engagement according to the meta policies. And we having your future version of a website where account insights also be added here, so it can be much more personalized and much more precise. And how the app